Hello everyone. Myself Ishita More and my group members are Sejal Gurke and Tejal Yadav. Our topic for article is study on upsampling and downsampling. This will be our flow of discussion: sampling, sampling rate conversion, multirate signal, upsampling, downsampling, program and output based on sampling, and the application. First, we will discuss about sampling. Sampling is basically a reduction of continuous time signal to a discrete time signal. The common example is conversion of sound wave to a sequence of sampling. So this is about sampling, and about sampling rate conversion. It is a process of changing a stream of discrete sample from one sample rate to another stream at a different sample rate. It can be done using a module called sample rate converter or a resampler in Python. So why to do sampling rate conversion? As it helps to prevent the change in speed and pitch that would otherwise occur when transferring recorded material between two systems or many systems. So how to obtain sampling rate conversion? As I said before, it can be implemented using a sample rate converter or a resampler. So now, first of all, we discuss about a multi-rate system. So as multi-rate, which means a multiple sampling rate. So it uses a multiple sampling rates within the system. It consists of two processes. First is decimation and second is interpolation. So decimation is basically to decrease the sampling rate, and the interpolation is to increase the sampling rate. So now we will discuss about the upsampling. So as a word is upsampling, which means increase. So it is a process of inserting zero sampling between original signal to increase the sampling rate. So this is the diagrammatic representation. X is an input signal and Y is an output signal. As the arrow is up, so it is an upsampling process where the zero is inserted between the original samples. So this is a basic idea where we are inserting the zero between the x of n and x of n plus 1 from an original signal. So this is the diagrammatic representation. This is the original signal and this is upsampled by 2. Like here, between 0 and t, the zero is inserted between these two samples. So this is a bad approach as we don't have an intermediate sample. So to generate it, there are two methods. First is repetition and second is interpolation. In the repetition, the two samples are repeated. Like here at 1 and 1 are two repeated at 0 and t by 2. In this this is another waveform where at 0 and t by 2 there are same sample. Similarly at t and 3t by 2 there are similar sample. Similarly further. Second method is interpolation. So interpolation is basically taking the average of two neighbors. So here at 0, if suppose it is 1 and at t it is 0.5. So the average of it is 0.56. So it is plotted at t by 2. So the purpose of upsampling. So the purpose of upsampling is to manipulate a signal in order to increase the sampling rate. And another is to add a samples to a signal to maintain its length while repeat of time, this with respect to time. So now Sejal will continue.
In signal processing, the downsampling is the process of reducing the sample rate of the signal. This is usually done to reduce the data rate or the size of the data. Here we can see the diagrammatic representation where X is the inputted signal, Y is the output signal, and here this is the downsam. This is known as the downsampling factor, which is usually an integer or a rational fraction greater than unity. Okay, as the arrow downward shows, it has a downsampling. Next slide. So yeah, let us consider a simple case of downsampling where a signal is converted to half of its original sampling rate. So here first figure shows the original sample and original signal, and the second figure shows the signal downsampled by 2. So for example, if a time signal of 10 seconds length with the sample rate of let's say around 1024 hertz are taken into consideration, So this signal may have valid frequency content up to the 512 hertz or half the sample rate, like as we discussed above. So if it was downsampled to the 5012 hertz, then the frequency content would now be reduced to 256 hertz. So this is an example for the downsampling. Next slide. So yeah, the purpose of sampling is basically, firstly, it is done to decrease the sampling rate, the main aim for performing downsampling. Then to remove the signal samples from the signal, like without disturbing the length with respect to the time. And third, and next we can say that to make a, for example, to make a digital audio signal smaller by lowering its sampling rate or sample size. So here the downsampling is done to decrease the bit rate when transmitting over a limited bandwidth, or to convert to a more limited audio format. Next slide. Here is the simple program for the upsampling and downsampling. Basically, this is performed using the functions known as upsample and downsample. Let's say we have taken X as an input signal like 1, 2, 3, 4. So here the Y is equal to upsample X, and 3 here denotes a factor and its offset. Like if suppose there is 3, then the zeros added between both the signal terms will be 3 minus 2 0. Then similarly, here C is equal to downsample Y3 shows that the signal that we got at Y, like using upsample, will be downsample, and hence indirectly we will get a original signal that about the original singular. Next slide. Here in this we can, as we seen in the code, this is the output for that. Here the first is the original signal. We can see the original signal, and then it is upsampled, and here two zeros are added in between every signal. And after downsampling this y, like upsampled signal, we get indirectly gets the original signal as the output. Next slide. So similarly, we have done upsampling for the audio signal. Here we have considered the inbuilt audio present in the MATLAB. Next slide. This is the original audio which we have took as an input, and next it is upsampled to this is the upsampled audio. Here we can see the x-axis ranges from 500,000 and so on. Next slide. Similarly, this is for the downsampling of the audio signals. We have taken the previous input original audio only. Next slide. This is the original audio, and now we can see it is downsampled to. Here we can see the downsampled audio. Next slide. So from here, Tejal will continue.
Now let us look at some of the applications of downsampling and upsampling. First, they are used for the design of phase filters and phase shifters. Next, they are also used in interfacing of digital systems with different sampling rates. And in digital audio systems, we need to access signals from different devices such as CD and MPEG. So there we require sampling rate conversion. In video broadcasting as well, we have different sources which employ different sampling rates, and hence we require sampling rate converters in these videos receivers. Next slide. Next, filter banks are used for analysis and synthesis of signals. So here also we have application of downsampling and upsampling. Next slide. Next application is in the implementation of narrowband low-pass filters, and eighth application is subband coding of speech signal. Downsampling and upsampling is also used in quadrature mirror filter. As we can see in the diagram, the input signal is first downsampled by factor of 2 in the analysis section, and then upsampled by a factor of 2 in the synthesis section before we get the output signal. Next slide. Then next application is in trans multiplexers. So these are devices used for the conversion between time division multiplex signals and frequency division multiplexed signals. We also have its application in oversampling analog to digital and digital to analog conversion. So while converting a signal from analog to digital, we use downsampling, and while converting from digital to analog, we use upsampling. So this is used for reducing the complexity, computational complexity, and reducing the transmission data rate. Next slide. Thank you.